In this problem, I've got an aluminum shaft, has a diameter of 60 millimeters, okay, and if I know the angle of twist between A and C has to be 0.06 radians, I want to figure out what this torque needs to be. Okay, so the first thing I need to do is determine what the torque is through each section. Section A, B, and BC, where I've got an abrupt change. I got an extra torque here at B. So through the A section, I've got the 2/3, AB section, I've got 2/3 at A. Okay, if I look at AB, that has to balance that force going in the opposite direction. Use my right hand rule. My right hand thumb points out of the shaft, which is a positive torque, as opposed to what's going on at C. So I've got a torque in this direction at C. Okay, so if I draw a positive torque over here, okay, that can't balance that. This has to be in the other direction. So that's where this negative sign comes from. I drew a positive torque, okay, but that can't balance this. If I look at this one, put my right hand rule around this one, my thumb will point into the shaft, meaning my positive torque here has to be in the opposite direction. If I do it in the opposite direction, my thumb points into the shaft, giving me a negative torque. Okay, so I have a positive torque 2/3 through AB, a negative 1/3 torque through BC. Now using my angle of twist equation, which I just sum up the two parts, I have TL over JG for AB and then TL over JG through BC. Recognizing that J is going to be the same since I have a constant 60 millimeter diameter. So it's pi over 2 times the radius, which is 30 millimeters to the fourth. So I get this for my polar moment of inertia. Okay. So plugging in my values, again, my angle of twist has to be 0.06 radians. I've got a positive 2/3 through AB and a negative 1/3 through BC, and that's really the only difference between these two, the positive 2/3 and the negative 1/3. Again, the lengths are the same, 1.2 meters. The J's are the same, we just calculated that because they've got the same diameter. And then 26 times 10 to the 9th, that is 26 gigapascals. That's the shear modulus of aluminum. So plugging all of that in, solving for T, I find that torque is about pretty close to 5 kilonewton meters is the maximum torque, so that the angle of twist does not exceed 0.06 radians between A and B. So again, just be careful with the sign conventions of your torques. Okay, this is a positive, this is a negative torque, and then sum up the TL over JG for each of the problems and solve for your angle of twist.